Hi, good evening, everybody. We will begin the class shortly. I just need to ensure that everybody can see this class publicly. So hold one moment. Okay, if you can see or hear anything, please let me know. Hi, Kaylin. All right, good to see you here this evening. Hello, Vanessa. All right, I'm just waiting for a few of you all few more students to come online, and then we will begin. How was the day? Okay, Jovan, Alicia, all right, Amanda, Lorez. Okay, I'm gonna start. Okay, I'm gonna start here. Um, just by way of information, um, the students who I actually teach in a school here, I saw a timetable up. That has no relevance to you. I saw they had class there scheduled for math. I have no classes in school, so that's probably for the other classes. Okay. All right, let's begin. Um, all right. So today we are dealing with day 3, and after I sat down and I plan out the class, I realized that we would have too much work to do if I try to put all the constructions questions together with the transformation and the trigonometry for question 3. So what I've done is put the transformations and the trigonometry, and I will have to actually extend the workshop by 1 day. I will tell you what the day will be. It will be Saturday night, Saturday 20th at 7 to 9 p.m. We will do the construction questions then. Okay? The reason why this question is like this is that when the syllabus changed, CXE took a question that was 1.5 questions and made it into 1 question. So they change between trigonometry and transformation. They interchange it from time to time, and you will see that in the past papers. Okay, so we'll just be doing the transformations as well as the trigonometry tonight, and we will deal with the constructions on the 20th of April. Now, I just want to share with you a quick motivational thought, and we get down to class. So, how many of y'all want to be successful in life? I hope everyone. Okay, but not everybody experiences success. So how do you go about getting it? Okay, sometimes we work hard and still we experience failure. So how do you get it? So one way to be successful is that, well, you have to take some steps. So I'm going to share with you 3 steps to really be successful, is to take incredibly small steps with a long-term perspective. So you have a plan. Let's say, for example, you want to be a doctor. You have to make a life plan for yourself. How do you achieve that? It means that you have to go to school and perform well at secondary school, get your CAPE done, or for some people, go and get a biology degree done, and then go on to medical school and so on. All right, and work at it, and you have to work well, and so on. All right, so you have to take small steps. So that's your plan, but the steps come with every day. And the next thing is that you need to put the right steps in the right order. So you can't be thinking about what you're going to be doing at A levels when you're not even doing well in secondary school. All right, you can't be thinking so much about what's going to happen in the future. You have to focus here now. So dealing with what's right there in front of you, okay, and over preparing like you cannot imagine that you would. So let's bring that same strategy here to your math now. In order to pass mathematics, you have to prepare properly. And that preparation started in Form 1, whether or not you believed it or knew it. All right. But the foundation that you built from then, you keep building until you reach the Form 4 and Form 5. And what you would notice is that if you don't have a good foundation, then you need to Jovan, behave, all right? Um, oh God. If you don't build a good foundation, what will happen is that you will have difficulty with the math in upper school. So you have to look at the things that giving you trouble in math. So if you're having problems with algebra, then focus on the things that are giving you problems and fix them, and then look to build on that. Okay? Now, putting the right steps in the right order. Many of you love to run down vectors and matrices, but you could barely work a simultaneous equation. Okay? So focus on the easier topics, make sure you can master them. And yes, aim to do the vectors and matrices, but make sure you could do the easy things. Okay? And over prepare like you've never imagined. Now, over preparation involves several things, and this links back with the second step, putting the right steps in the right order. Many of you rush to do past papers, and what you realize is that if you're rushing to do the past papers and you don't know the mathematics, what will happen is that you will frustrate yourself. So take some time to learn the theory first. You must know the theory, and that's about putting the steps in the right order. You have to know the theory before you could do the mathematics. So take the time, understand the theory, look through the syllabus, look through your textbook, practice some questions, understand the theory, and then come and do some past papers. And that's how you start to become successful with it. That's where it becomes easy. Okay? So I hope that you will apply those things as we go through tonight's class, and you'll realize that as we do the questions, there are deficiencies in your knowledge. Go back, identify them, because I will not be able to stop and teach everything because things gonna get difficult tonight. So let's focus. Let's get some work done. For the people who are new, my name is Mr. Khan. Welcome. Um, we have a lot of moderators here, students, teachers who are moderating the chat. So if you misbehave and start to spam the others, then they will just remove you. Okay, so let's begin. All right, so we'll be looking here at January 2019, paper 2, question 3B. The diagram below shows a right angle triangle with sides A units, B units, and C units. Part 1, using the diagram. Part A, express C in terms of A and B for 1 mark. So they want you to express C in terms of A and B for 1 mark. So I want you all to try that. Go ahead and try it. What do you think you will use? Okay, the square root of a squared plus b squared. But how are we coming up with that? We're using Pythagoras theorem, right? So we know that Pythagoras theorem states that the hypotenuse squared is the sum of the squares of the other two sides. So I will write that here. And if you forget this, which you hopefully you shouldn't, it should be in the formula sheet in the front of the exam, right? So by Pythagoras theorem, the hypotenuse squared is equal to the sum of the squares of the other two sides. So therefore, we could just make this C the subject of the formula here. So C is equal to the square root of a squared plus b squared. So that's the answer there. Okay? So let's go to part B. Part B, write in terms of A, B, and C an expression for sine theta plus cos theta for 2 marks. So try it. Tyrell, why I chose to not express it as c squared is equal to a squared plus b squared is because they asked me to express it as c in terms of a and b. I made c the subject of the formula. I didn't just use Pythagoras theorem here and remain there. Okay? Kiyomi, simplify that further. Notice that the denominator is c there, a over c plus b over c. What you could do with that? Yes, it is hard. It feels like odd maths, right? A plus b over c, all over c, yeah? So, Leah, the better thing to write there is open brackets a plus b, close brackets all over c. All right, so let's start the working here. For those of you not sure how you're not how I'm coming up with this, let's look at what sine theta is. Sine theta is opposite over hypotenuse. Okay, and when we go to the diagram here, all right, this is the angle under consideration. This is the side that is next to the angle, so we call it the adjacent. This is the side that is opposite the angle, so we call it the opposite. And this is the longest side of the triangle and is opposite the right angle. We will call it the hypotenuse. So sine theta is equal to opposite over hypotenuse. The opposite here is A and the hypotenuse is C. So this will be A over C. And cos theta is adjacent over hypotenuse. And in the diagram here, the adjacent here is B, the hypotenuse is C. So therefore, cos theta is B over C. So we write the expression they gave us here, sine theta plus cos theta is equal to sine theta is A over C, cos theta is B over C. Notice here that the denominators are the same, so we add the numerators. So this is A plus B all over C. Okay? All right, so I'm going to move on here to part C and part 3. All right, go ahead and try this part here. This part is a little more challenging. Okay, Naomi and Nathaniel, given my experience with you guys over the past few days, I expect you all to be lost for this. This is a bit more advanced. Okay? Do what I suggested in my little motivational talk. Sit down and try to learn the theory because you will be confused with this. All right, you have to know the theory. Okay? We're not doing 3-8 today. I said that I added a day to the workshop, so on the 20th of April, we will do all the construction questions because it's too much to fit in the 2 hours. Okay, I don't want an information overload. I want to make sure that you understand what you're doing. Okay, Tania? So tonight I'll do the trigonometry and the transformation questions. Okay, let's start here. They have here, they want us here to, using the results from part 1a and b on page 12, show that sine theta squared plus cos theta squared is equal to 1 for 2 marks. Now, what we have, when they say show that, this is what they want us to take, start with sine theta squared plus cos theta squared and use the results from parts A and B, plug them in and see and show that you will get 1. So I'm going to do that here. So I'll write here sine theta squared plus cos theta squared. All right, now we know that sine theta is A over C and cos theta is B over C. So sine theta is A over C, and this is all squared for sine squared here, plus cos theta here is B over C, and this is all squared. So by the laws of indices, this becomes here A squared over C squared plus B squared over C squared. And notice again, the denominators are the same, so we can add the numerators. So this is A squared plus B squared all over C squared. Now, we know here by Pythagoras theorem that C squared is equal to A squared plus B squared. So I'm going to write here by Pythagoras theorem C squared is equal to A squared plus B squared. So what I'm going to do here, wherever I see A squared plus B squared, I will substitute C squared. So therefore, I'll call this equation 1 and I'll call this equation 2. And I'll sub here equation 2 into equation 1. So here we have sine theta squared plus cos theta squared, and this a squared plus b squared will be c squared over c squared, which is equal to 1. Okay? And QED. This is usually written at the end of a proof. Okay? Tishon, I would not try to go and make too much explanation for you for the weaker students with this, because this is a little more challenging, and if you don't understand your trigonometry, you're gonna have problems. So let's move on. Okay, this is, sorry, wrong paper. That was it. We actually finished a part there. So let's go to May 2018 now. This is 3B. The diagram below shows the triangle OPQ. Part 1, state the coordinates of the point state the coordinates of the point Q for 1 mark. So we go to the graph here, and I want you to, let me just bring this down a little bit there. State the coordinates of Q there. Okay, so you'll notice that 4 on the X, 1 on the Y. So I'll write here, oh boy, Q is 4, 1. Okay? Part 2, the line PQ is mapped to P prime Q prime by an enlargement, center O and scale factor 3. On the diagram, draw the line P prime Q prime for 2 marks. So I want you to work out that. You need to do some calculation to show how you're coming up with it. Okay? You all know what to do? At least type in the chat and let me know now. Sure. The graph is there. All right. Yes. Yeah. Nope. I'm seeing that look like Russian. Oh, just some kind of, no. A little. All right. Let me help you all set it up a little bit, and maybe it will be easier for you. Okay. So we know from the diagram here that P here is equal to 2, 2, and Q here is equal to 4, 1. So let's start with that. We write down that first. P here is equal to 2, 2, and Q here is 4, 1. All right? And for the enlargement about the origin with scale factor K, what you do is that for the point here, X, Y is KX, KY. All right, that's the formula you're using. So for those of you who know what you're doing, continue from there. All right, work out the enlargement of P and Q. 6, 6, I'm seeing 6, 6. 6 is for P prime. What you all have for Q prime? Gita, that is not correct. All right, you're looking for 6, 6 for P prime, and Q prime, you're looking for 12, 3. Yes, P prime is 6, 6. Now you need to learn this, huh? Good, Tyrell. All right, so gonna continue here about the origin here, and the O is the origin, and the scale factor K here is 3. So let's deal with P. P here is 2, 2. All right, and we want to enlarge P, and we'll get an image here of P prime, and this is 3 multiplied by 2, 3 multiplied by 2. So this gives P prime here is 6, 6. We're going to enlarge Q now about the origin with scale factor 3. Q here is 4, 1. Q prime here is 3 multiplied by 4. And this is 3 multiplied by 1. So 3 multiplied by 4 here is 12. 3 multiplied by 1 here is 3. Okay? So this is the formula you're using, and you locate the points P prime and Q prime. Now, what we do is we have to locate these points on the graph now and draw a line. So I'm going to do that here. All right, so I locate here 6, 6, and I want to go to 12, 3. So this is 6, 6 here. Oh boy. All right, sorry, this takes a bit of a time here. All right, I'm not sure. Six, 6 to 12, 3. All right, that's what you're supposed to have there. Okay. Chad, obviously I can't reuse a ruler here. Think now. All right, let's move on. Part 3. Yes, part 3. The triangle OPQ undergoes a reflection in the line y is equal to 0 to produce the image O double prime, P double prime, Q double prime. On the diagram, draw the triangle O double prime, P double prime, Q double prime for 2 marks. So I want you to go ahead and do that. I'll just leave this up a little bit and then you'll go back and do it, okay? All right, I'm going back to the graph now to allow you to finish your work. I'll take this up a little bit. Okay, for those of you who are a little lost, triangle OPQ undergoes a reflection in the line y is equal to 0. Y is equal to 0 is the x-axis. And when you're reflecting in the x-axis, what happens? The x-coordinate remains the same and the y-coordinate is multiplied by -1. Okay? So if you go back here and you are reflecting here, OPQ, triangle OPQ, the origin and the points P and Q. So reflect them. All right, the x coordinate remains the same, the y coordinate is multiplied by -1. All right, so this will be 2 minus 2, 4 minus 1, and 0, 0, because -1 multiplied by 0 is 0. I'll work it out in here. I'll work it out in detail. I just giving you a quick heads up to start. All right, so you'll write out here what you have. The origin here is 0, 0. P here is 2, 2. And Q here is 4, 1. So you could either write mx as in the mirror line or the reflection in the x-axis, or y is equal to 0. Y is equal to 0 is the same thing, okay? xy, x minus y. Now, this is the general rule, okay? And you need to remember this. When you're reflecting in the x-axis anything, all right, any point, the x coordinate remains the same. So you see, the x remains the same and the y coordinate is always multiplied by -1. So for each of these points here, we're going to do that. So the reflection of O has coordinates of 0, 0. You will get O prime here. O prime, not Q prime here. All right. And this is 0 and -1 multiplied by 0, which is the same as, well, this is O double prime. Sorry. O double prime, 0, 0. And you're doing the same for the other two. So the reflection in the x-axis of P, and P has coordinates of 2, 2. So P double prime here, remember the x coordinate remains the same, and the y coordinate 2 here is multiplied by -1. Okay, so P double prime here, the 2 here remains the same, -1 multiplied by 2 here is -2. All right, the last one here, Q, is 4, 1. So when you reflect this in the x-axis, Q double prime here, the x coordinate remains the same, the y coordinate is multiplied by -1. So Q double prime here is 4, minus 1 multiplied by 1 here is minus 1. Okay, so now what we want to do here is to draw this triangle here. Okay, that's how you came up. So is it necessary to do all that working? They gave you this for 2 marks. I would prefer that you do the working simply because it shows how you come up with it. Okay? I would prefer if you do the working. All right, I recommend it. It's always the best thing to show how you come in. Obviously, you could simplify this working somehow, like the middle here. You could probably skip it out or do something to simplify it in some way. Okay, because you already have the generalized formula here. So let's go to the diagram here and let's plot it. So I'm going to use a different color here. So P double prime is 2 minus 2. So I'm going to go down here. Q here is 4 minus 1. Oh, that's Q double prime. Sorry. All right, and then we need to just connect the origin here to 4, 1. And we're good there. Okay, this is a little tedious to do here, okay? All right, so that's it. I hope everybody gets in this, huh? Because it's supposed to take me longer to do it than you, given that how I have to draw with this tool on the computer here. All right, so that's the end there of May 2018. So let's look at January 2018, paper 2, question 6. The diagram below shows triangle PQR. State the coordinates of R for 1 mark. So we go here. Tell me what's R. Yes, young strikers, basically mirroring the point, the plotted shape. That is what is a reflection. It's a mirror or image of it. All right. So 0, 3. All right, 0, 3 is correct. So let's write that in there. This one was easy. This part at least. All right, it gets challenging after. So R here is 0, 3. All right, so part B. On the diagram, draw part 1, triangle P prime, Q prime, R prime, a reflection of the triangle P, Q, R in the line y is equal to 1 for 2 marks. So before you run ahead and draw anything, you need to identify the line y is equal to 1. So you see this point here? All right, on the y-axis, y is equal to 1 is a horizontal line. So I'm going to draw that horizontal line first, and then I want you to do the reflection. I hope you all realize that that was the line y is equal to 1, okay? So go ahead and do the reflection now. Now listen, if you don't fully understand the mathematics, you could at least write this. So please, it's very simple. Just count the distance from the mirror line to each point. The distance for any reflection from the mirror line to the point and the image is the same. So you see, from P to the mirror line here is 1 unit. So from the mirror line to P prime will be 1 unit as well. All right, the same thing goes to Q. 1, 2, 3, 4. So you will count 4 blocks down, 4, all right, to get Q prime. Same thing for R. No, no, Kayla, the scale isn't different on the y-axis. What happened is that they just numbered every 2 centimeters. But the scale isn't different. It just looks that way. Could you just indicate in the chat if you got it? You don't need to tell me all the points. I just need to know if you finish with plotting the points. I'll know if to start. You know what? Seeing that it takes me a while, let me start. Okay. So the distance here from P to the mirror line here is 1 unit. So you're gonna start here. P prime will be here at 2. I'm gonna take this up a little bit. All right, and go down to Q here. 1, 2, 3, 4. So 1, 2, 3, 4. Good. All right. Okay, so for R prime here, 1, 2. So you're counting 1, 2. All right. All right, so let me label out these points here. So this will be P prime, this will be Q prime, and this will be R prime. Okay? All right, good. So this was B part 1 here, the reflection here of triangle PQR, all right, in the line y is equal to 1. Now for part 2 here, we want to deal with the reflection here, triangle P double prime, Q double prime, R double prime, a reflection of triangle P prime, Q prime, R prime in the line x is equal to 0. What is the line x is equal to 0? The line x is equal to 0 is the y-axis, so I'm going to draw in that mirror line first and you'll do your reflection, okay? Which part, Adrian, you want me to explain? All right, I'm going to go ahead and wait and explain. They want us to reflect this first triangle, PQR here, right? In the line y is equal to 1. So I locate y is equal to 1 here, and this is a horizontal line. That's my mirror line. And in order to find the points here, the distance for any reflection from the mirror line to the point and its image is the same. Okay? So from P to the mirror line is 1 unit. So therefore from the mirror line to P prime will be 1 unit. The same goes to Q and Q prime. 1, 2, 3, 4. So therefore 1, 2, 3, 4. And for R here, this is 1, 2. So for R prime, this will be 1, 2. Is that clear, everybody? All right. So I want now to plot the line x is equal to 0. This is x is 0 here, and this is a vertical line. So let me plot that out for you. I'll change the color there. All right. So it's a different color. It's purple there. So go ahead now and reflect that. Use the same principle, okay? We are reflecting here R prime, P prime, P prime, Q prime, R prime. Okay? This one here. That is what we're referring. I'm reflecting. Use the same principle. Okay, so I'm going to start a plot here. Notice here that P prime is 2 units away from the mirror line, so therefore P double prime will be 2 units away from the mirror line. Okay, and the same way Q prime here is 2 units from the mirror line, so therefore Q double prime here will be 2 units away. All right, R prime is on the mirror line, so R double prime is equal to R prime. It has the same location. Color, not try blue. Okay, y'all got that? Did you get that? So this here is Q double prime. This here is P double prime. Okay, and R double prime. Though you can't see that there. Put it down here. All right, this is the same point. R double prime is equal to R prime. Okay? Did everybody get that? Okay. All right, but the basic principle is that you count the number of units away from the mirror line, and you must know what x is equal, the mirror line x is equal to 0 is, as well as y is equal to 1. If you get your mirror line wrong, you'll have problems, okay? All right, great. That's the easy part. Now comes the challenge. Part C. Describe fully the single transformation that maps triangle P double prime, Q double prime, R double prime onto triangle PQR for 3 marks. All right, so let's go to the graph here. And let me explain to you what to do, because I don't have the tools necessary to do this. But I will set it up for you. And this, you'll need your compass to do this, huh? Okay? So in order here, you would notice here that PQR here and P double prime, Q double prime, R double prime here, you would notice here that it is opposite each other, and it looks like a rotation for sure. Okay, because think about yourself, you're standing upright and then upside down. Obviously you made a rotation. Now it is a rotation 180 degrees, but you have to actually find the center, and in order to find the center, you have to do some work here. Now, Janelle, you are correct. 180 degrees clockwise or anti-clockwise at 0.01. That is correct. But you have to locate it. And there's a technique to do it, a proper technique to do it. So I'm going to just guide you through. What you do here is that you have to connect here. Excuse me. Okay, so the center of rotation, you have to connect here P to P prime and P to P double prime. So this is P double prime here. Oh boy, sorry, yeah. This was supposed to be a line. Okay, so this is P to P double prime here. And what you will do here, you will bisect this line. You bisect the line by opening your compass a little more than half. Okay? And you will scribe arcs here and here. Come on this side here at P and use it as the center and scribe arcs to intersect each other and draw a perpendicular bisector. I know it sounds like work, but that's what needs to happen. And in the same way, well, you already have here R to R double prime. You could connect it here. All right, well, you have it here. I'll just do it in another color. And you will bisect this line again by opening all the compass a little more than half, scribing arcs using R and R and R double prime as centers, and you will construct the perpendicular bisector, and you'll notice here that they will pass through 0 and 1. All right, I know it sounds like real work. All right, and that's how you locate your center. All right, so let me write out the statement now. So the triangle P double prime, Q double prime, R double prime is mapped onto oh Jesus. Triangle PQR by rotation of 180 degrees in the anti-clockwise or clockwise direction. Remember, it doesn't matter if you turn clockwise or anti-clockwise 180 degrees, you'll still end up at the same place. About the center, zero, 1. All right, and that's the answer there. Genti, so it couldn't be done by connecting all the points and the point that all the line crosses at the center. Really and truly, I would show you how to do it properly. By what I showed you there, that is the proper method to do. Yes, you get the same answer in this case, but let's say you have to deal with a rotation 90 degrees, that wouldn't work. Okay? That wouldn't work if you rotated 90 degrees. So in this case, it happened to work like that. So do the proper method that I mentioned there. Connect the object to its image and bisect the line. You do it for 2 points and you'll locate the line. You don't need to do it for 3. Okay? Part D. Triangle PQR undergoes an enlargement of scale factor 2. Calculate the area of its image. So go ahead and do this, please. All right, I'll give you a little time. No, the center cannot be 0 minus 1. Center has to be 0, 1. Yeah. Scholar, where you want me to go back to? The area is 12 units squared. All right, so let me set it up here. They gave us the scale factor K is 2. All right, and the area factor is K squared. All right. Let me write this out clearly so that you all will understand, because some of you may not remember your theory. So scale factor is K and is equal to 2. The area factor has this symbol K squared, and is the scale factor, is the square of the scale factor. Okay? So therefore, let's go to the graph here. PQ here has a base of 3 centimeters. 3 units, sorry. PQ is equal to 3 units. All right, and this is my base. Okay, PQ is my base. All right, the height here, you would notice here is 2 units from here. 1, 2. That's the height. Okay, so area is equal to base multiplied by height divided by 2. This is equal to 3 multiplied by 2 all over 2. That cancels. So you get 3 units squared. Well, 3 units squared. All right. The area of enlargement now, because they want us to find the area of the image. Is K squared, so always the area factor squared, multiplied by the area of triangle PQR. And K here is 2, so this is 2 squared multiplied by the area of triangle PQR is 3 units squared. So this is 3 units squared. So 2 squared is 4, 4 multiplied by 3 here is 12. So this is 12 units squared. Okay? So that's how they come up with it. You find the area of triangle PQR, which is what we did here. All right? And to find the area of the image, or the, all right, we take this area factor, which is K squared, and multiply it by the area of the origin, well, the triangle PQR, the original image. Well, not the original image, the original object, or the object. The object is the correct one, not original object. Keelan, you'll have to look this over. Okay, I'm moving on here now. May 2017, paper 2, question 5. PTRS not drawn to scale is a quadrilateral. Q is a point on PT such that QT is equal to QR, which is equal to QP. Angle QRT is equal to 76 degrees. Part 1. Determine, given a reason for each step of your answer, the measure of angle RQT for 2 marks. So you look, trying to find here RQT. Go ahead and do that, please. Guys, you would notice that I'm moving faster, much faster tonight. The truth is that if even I had stopped for the slower students, you have to know your theory for this. All right? You have to know your theory for this. And if you don't know your theory, it's not, no more amount of explanation will help you with this. Okay? You all know that I'm willing to slow down if I need to, but it's not going to help you otherwise. You have to sit down and memorize your theory, okay? Doki, I hope you know how to do this, brother. Alright? No, come on, give me no yeah here. No, Shane, there'll be no add math. I'm just doing math. Okay, they want us here to find here angle RQT. RQT. So this is the angle they want us to find. Notice here that this is an isosceles triangle, which means that the base angles are equal in an isosceles triangle, right? So this here is 76 degrees. Okay? So all I'm doing here is 180 minus the sum of this. All right? Everybody clear with that? So angle R, well, angle RTQ is equal to angle QRT. All right, and the reason is base angles of an isosceles triangle. All right, so angle RQT is equal to 180 degrees minus the sum of angle RTQ plus angle QRT. So this is 180 degrees minus here 76 degrees plus 76 degrees, 180 degrees. Okay, so this is 152 degrees. This here is 28 degrees. Okay, that's the answer. Part 2, angle PRT. Angle PRT. So I'm going back to the diagram here. Angle PRT. Angle PRT, all right, is this whole angle here. Okay, now we found here to be 28 degrees. So that should help you out. You know, angle of a straight line, find here. And you could see that this is isosceles. So you could find down there. If you find down there, you could add to there, right? Jovan, check over your working rather than take the time to write, say, so 28 wrong like that, okay? It wrong. All right? Your working is wrong. Okay, so let me help you out here. We know that this is 28. What's the angle of a straight line? The angle of a straight line here is 180. 180 minus 28 is 152. All right? And we know that this is an isosceles triangle, so which means that the base angles are equal. So this 28 divided by 2 here will give 14. So this is 14 degrees. And 14 degrees here plus 76 is 90 degrees. How many of you all get to 90 degrees here? What just now, they want you to find angle PRT. Yes, 90 degrees. Anybody got the 90 degrees? Is it that I'm not seeing the chat properly? Let me go it over again because this is pretty simple, okay? We know that this is 28 degrees. We know that the angle of a straight line is 180 degrees. 180 minus 28 is 152. You see in these signs here? This indicates that this is an isosceles triangle. So we know that the base angles of an isosceles triangle are equal. So we know that 180 minus 152 here is 28. 28 divided by 2 here is 14. Okay? And they want you to find here angle PRT, which is this whole angle here. So 14 plus 76 is 90 degrees. That's how I got it. All right? If you don't understand, you'll have to look it over, okay? So let me write out the working here now. So angle PQR is equal to 180 degrees minus angle RQT. And the reason here, this is a straight angle. So this is 180 degrees minus 28 degrees. And this is going to give me here 152 degrees. All right? So that accounts for here. That accounts for this. Now we have to find this. All right? So angle PRQ is equal to 180 degrees minus 152 degrees divided by 2. All right? This was 28 all over 2, which is 14 degrees. And the reason is this is base angles of an isosceles triangle. Okay, so what I'm doing here, the base angle here is 14 degrees. That's how I get that. Now for angle PRT, I'm just going to add up these two angles here. So for angle PRT, this here is angle PRQ plus angle QRT. All right, so this is 14 degrees plus 76 degrees. And this gives a grand total of 90 degrees. Naomi, you'll really have to revise your geometry, all right, to understand why I divide by 2. All right, this is why I keep emphasizing you have to sit down and learn the theory. I understand that you're weak, but you can't just face the fast papers just so without learning the theory. Okay? I wrote the reason right here. Base angles of an isosceles triangle. Okay, so this was May 2017, and we just have part B to do and we're done. No, we have this part here. Angle SPT, given that angle SRT is equal to 145 degrees and angle PSR is equal to 100 for 2 marks. So let me just go back to the diagram here. All right, they gave you here that angle, let me just erase this so I wouldn't confuse you. Angle SPT is equal to, all right, that's what they want to find. And they want you here, they give you SRT to be 145 degrees. And they gave you here PSR to be 100 degrees. Okay, so use that information there. The first thing you'd want to do is to put it into your diagram. So put it into your diagram, please. So angle PSR is this angle here, and this is 100 degrees. And they gave you here that angle SRT is equal to 145. SRT is 145. So this whole angle here, this entire angle here is 145 degrees. Okay? Janelle and anybody else who put 39 degrees, that is correct. If you have anything else, Zaria, if you have 25, you have some working to do still. Okay? You're close. You're not wrong. All right? You're on your way. Tyrell, that's a nice suggestion, you know. Okay? But in a large class like this, it's really hard to give feedback to everybody. Or that's why when you have lessons and then you have to limit your classes. Otherwise, students will not get a proper education. Tyrell, anybody have free time now, boy? Now is crunch time. I'm not seeing enough 39s here, but I'm going to start to work. So angle PRS is equal to angle SRT minus angle PRT. And this here is equal to 145 degrees minus 90 degrees. This is equal to 55 degrees. Angle SPR is equal to 180 degrees minus angle PSR plus PRS. All right. And the reason here is the total interior angles in a triangle is 180 degrees. Okay, so this is equal to 180 degrees minus 100 degrees plus 55 degrees. This is 180 degrees minus 155 degrees. This is equal to 25 degrees. Sorry, I think this is where you reach and that you gave me the 25 degrees. So angle SPT is equal to this 25 degrees plus the 14 degrees. Okay? This is the angle that they want you to find, right? So we had to work out this. So the 145 minus the 14 minus the 76. This gave you the 55 degrees here. All right. And the 180 minus the 155 gave you the 25 degrees. All right. And they wanted you to find here this angle, SPT. Okay. So that's how you're adding it up and you're getting 39 degrees. Okay. All right. So let's go on to part B. The diagram below shows triangle ABC and its image A prime, B prime, C prime under a single transformation. Part 1. Describe completely the transformation that maps triangle ABC to triangle A prime, B prime, C prime. All right. So I want you all to go ahead and do this. Look at it carefully. Is this a reflection, class? Put in the chat, is this a reflection? Before you run and do anything. Yes. Kevon, that's a rotation. That's correct. All right, it's not a reflection. So that technique I told you all about to find center of rotation, that is where it comes in now. Okay? So you have to draw a line from B to B prime and bisect it. Yes, Janelle, it's 90 degrees in the clockwise direction, but you have to come up with it. You have to show how you're coming up with it. So you will draw a line from B to B prime. Okay, so you have one line there and you will bisect it. You will take your compass and use B and B prime as centers, open it a little more than half, and scribe arcs on both sides here and bisect this line. Then you will do the same. You could connect any other 2 points, C to C prime or A to A prime, any one you want. All right, and do the same. Bisect it, and you will locate the center. Okay, and when you bisect this line here, you would notice that you would get down to the origin. Okay, the center of the center of rotation is the origin, not the center 1 1. Okay, like I said, I don't have the tools to do it online here, but I'm giving you the procedure as to what to do. You draw a straight line from B, you connect B to B prime, and you bisect the line, and the perpendicular bisector that you draw would be straight down here along the y-axis. You connect here C to C prime, you bisect the line, and you will notice that it will pass through the origin. Both lines will intersect here. Okay, so your origin your center of rotation is you're rotating here. Now because you're rotating this way, this is clockwise. Okay, the rotation is clockwise because you notice that A to A prime is in this direction. If it was going in this direction, it will be anti-clockwise. All right, so it's clockwise. The rotation is clockwise for those of you who are inquiring. All right, so this is your center of rotation here, 0, 0. Okay. Y'all, this is not January 2019, eh? This is May 2017. Okay. So let's write out the description here. Triangle ABC is rotated 90 degrees in the clockwise direction. To A prime, B prime, C prime, with the origin as the center of rotation. Okay? So that's your description there. Now let's deal with part 2 here. The translation vector t is 4 minus 5 here. And it maps a triangle A prime, B prime, C prime to triangle A double prime, B double prime, C double prime. On the diagram above, draw triangle A double prime, C double prime, B double prime, C double prime. So what you could do here is just translate each of the points. Okay, so I'm going back to the diagram here. Sorry, I went up too far. Okay, they want you, the vector here is 4 minus 5. So t here is 4 minus 5. Do this translation, please. Y'all, I'm not sure what you're talking about. I honestly don't know what you're talking about. To be honest with you, I really cannot hear myself. I am speaking to you all, and the only way I could hear myself is when I listen to the recording of all of this after. Okay? And listen, all this story about buck hunting, please, you all focus on the mathematics. Just focus on the mathematics. I honestly don't know what is the problem. Maybe my computer is giving problems. All right. This is yeah, we almost done. So to be honest with you, it's not important for me to really go back and look at it. So I have better things to do with my life. I'm waiting for you all to do the translation and draw A double prime, B double prime, C double prime. Tyrell, I have my days where I could be blunt. Some days I have to pray for myself, all right? All right, but I do care about my students. Otherwise, I would not have been doing this. Okay. All right, Naomi. So we have the translation vector here. So I'm going to write out the working here. Now for translation, this is really simple. What we have here is the object plus the translation vector is equal to the image. So for A prime plus the translation vector here t, you will get A double prime. And you all, I'm writing out the working here. So the A prime here is 1, 4 plus the translation vector here is 4 minus 5. Let me write this a little neater. Is equal to 1 plus 4 is 5. 4 minus 5 here is minus 1. So A double prime here is 5 minus 1. Okay, in the same way, B prime plus T is equal to B double prime. So B prime here is 1, 1. The translation vector is 4 minus 5. And B double prime, 1 plus 4 is 5. 1 minus 5 here is minus 4. Okay, the last one here, C prime plus T is equal to C double prime. C prime here is 3, 1. The translation vector is 4 minus 5. And this gives me 3 plus 4 is 7. 1 minus 5 here is minus 4. So what I'm doing here, I'm plotting the points here. 5 minus 1, 5 minus 4, and 7 minus 4. How you got B and C to be 5 minus 4? How is it possible to have 2 points having the same point when you do a translation? That is against the general principle of a translation. Leah? Alright, I'm going to the diagram here and plot out the translation. Take this up a little bit. Let me just plot the points here so you could see. A double prime is 5 minus 1, so this is 5 minus 1 is here. B double prime is 5 minus 4, so 5 minus 4 is here. Okay? And C double prime is 7 minus 4. So this is 7, and down here is minus 4. Alright, so I'm just going to connect these points here. Okay. Alright, let me just fix this a little bit there. Alright. And you all, that's it. Okay? That's it. Leah, it's doing it from the graph isn't wrong either, you know. If you're translation, you just count in. It will be 4 across and 5 down. Okay? So for C prime, let's do it like your way. All right? 1, 2, 3, 4. That's 4 across. 1, 2, 3, 4, 5. You see I'm getting the same thing? Let's go to B prime. 1, 2, 3, 4. 1, 2, 3, 4, 5. You see that? Okay, so this is B double prime. This is C double prime. Now, let me just take this up here a little bit. All right, and let's do A prime here. 1, 2, 3, 4. 1, 2, 3, 4, 5. You all see we get to the same thing? Everybody see that? So there are many ways to do the same thing in mathematics, okay? Okay, well, y'all, this is the end of the class today. We have covered everything that we set out to do. I hope you all learned something, and I really couldn't go slower because this is challenging work, and in terms of the students who know their theory and thing would be able to get this, but I can't sit down and just go through this slowly. Okay, that's great, Leah. You get to see through your get to identify your error and make the corrections. Okay. You all have a good evening. I would see you all tomorrow at 7 p.m. We are doing question 4, the functions. Okay? We are doing the function questions tomorrow. So have a good night. Take care, everybody.